Good morning, everyone. Today we're going to talk about a different angle system. Just when we thought we had a handle on things, life can get a little more complicated. Up till now, we've been dealing with the mathematical angle system in which 0 degrees starts out here and angles are measured in this direction. In other words, an angle such as this might be 225 degrees. And this is what mathematicians do. And it's a wonderful system. Sadly, in our messy little world, there's another system that's very, very prominent. And we're going to talk about that today. The system of mapping, I'll say transportation. Let's just say that. Engineering. Of course, they use a different system. And in this system, 0 degrees starts up here, aka north, and angles are measured not counterclockwise as mathematicians do. Oh no, let's try to be different. Angles are measured clockwise, from north being 0 degrees. And it's not a big deal, but definitely will take some adjustment. So now south is our 180. So that angle is something, let's say, 165 degrees from north, clockwise. Yeah, I know. And just when you kind of have a handle on that, it gets even worse. There's also a system, again, heavy on mapping, where you can have something that also references east, west, and south. And you may have seen these if you've done any kind of orienteering, geocaching, something like that. You may have seen these. So the quadrant 1 is no problem. Something like that. There's north. If this angle is 50 degrees, we say north 50 degrees east. And this is called a bearing. So that's no problem, but it gets a little trickier when you start looking at north 50 degrees east has an evil twin down here in quadrant 3, and it would be, you guessed it, south 50 degrees west. Yeah. Again, not too bad. You start at south and you go clockwise 50 degrees west. And accordingly, you can have something out here. I was going to go green on that. You could have something out here. What would that be? Well, it starts at north. This one, however, goes counterclockwise. Yeah, north. Did I go 50 again? Yeah, 50 degrees west. Yeah, just when we get a handle on things, this system comes into play. So all of these come together to mess with your mind a little bit, but it's okay. We'll get used to them. At first, they might seem a little cumbersome, and they are, but it's okay. What's this one? Yeah, you guessed it. South 50 degrees east. So, confused? Probably. It's okay. We'll get used to it. We'll work with some of these. Next up, we have azimuths. Azimuth. Maybe a little bit simpler system. This one I alluded to at the beginning of the vodcast. This one goes north is 0 degrees. I guess let me move this over. North is 0 degrees, and everything is clockwise from north, such as this. An object out here. Easy way to think about it is, well, where is 180? Straight south is 180, and then that's another, I don't know, 30 degrees. So that would be an azimuth of 210 degrees out to there. Azimuths are also known as headings. If you are a pilot, a person driving a boat, person driving an aircraft, they fly on a heading. And again, they go from north being 0 clockwise to the right. Clockwise, not counterclockwise, not 0 east like we do in math. So, as is often the case, we need to be bilingual, and that's okay. So let's do an example problem and see what that looks like. No, we need a new page. So here we go. A plane flies A plane flies 600 kilometers on a heading of 300 degrees. It then flies south for a while. The air traffic control probably redirected them. And notice a while is not specific. And finally flies on a heading of 40 degrees to return to its starting point. Maybe this is a young person getting their pilot's license. So we'll go with that scenario. So it's someone learning to fly. And our task is to find the total distance traveled. Okay, we can do that. Well, let's start out with a cool drawing. So 600 kilometers. So let's say we start in Monmouth. And it says a heading of 300 degrees. Oh, I see already. I'm going to have to change that because 300 degrees is in quadrant 2. So we are starting, let's say we'll start here. We're going to fly 300 degrees. Now, one thing I like to do is say, well, this is going to be 270, 90, 180, and 0. So 300 is going to be 30 degrees past 270. So we're flying 600 kilometers on a heading of 300 degrees. So that would be from, if we left Monmouth, that would be north and west a little bit. If you're thinking about it as a bearing, it'd be north 60, west. Same thing. I wanted to go red. We could also say that this is north 60 degrees west. It's 300 degrees if you're going clockwise from 0 as a heading or an azimuth to some point. And at that point, we turn south, and it doesn't tell us how far we're going. We're just headed south. And then it says at some point we go 40 degrees to return. Okay, so right now, if I return from right here, that would not yet be 40, but we're getting pretty close. So again, the trick is to think of this as, let's say we turn right here. And now north is new. Every time you take a new heading, north now becomes right here 0 degrees. And in blue, I'm saying, oh, okay. And my scale is probably not correct, but that's okay. Now my heading is based off a new north. That's the big takeaway.
Teachers, excuse the interruption. There's a staff meeting in the library. Staff meeting in the library right now. Thank you.
So our heading is 40 degrees. Now, here's the tricky part. So north, from this perspective of this red point right here where we turned, north is now 0 degrees, and we measure our heading 40 degrees. And we're saying, what is our distance? Well, now we have our triangle, and let's think about this. This angle is 60. This angle is 300. This little angle, and I'll just put it here in blue, is 40. So then we would say, well, what's this angle in here in red? Right there. Okay. Well, 300, my reference, or my grid here, I said was 270 from here, 90 from there, I guess you'd say. So that would be 300 minus 270, 30 degrees for this little one in here, 40 degrees here, 40 degrees here. And so that total angle then would be 70 on the inside. Okay. Wait a minute. No, I think I might have goofed that up. I'm allowed to make mistakes. Let's see. We said this angle was 40 from north. Oh, I lied. I completely lied. Probably because my scale is whacked. This is not. Oh my goodness. Okay, changed my mind. I'm not even going to rely on that one. Okay, how about we go this way? We know that that's a 90, and we said that this one here we know is 30. That means let's go green up here. This will work. That one then has to be, if this is 30 and this is 90, that one has to be 60 degrees. Okay, now we've got our triangle. Notice that this is 40 down here. This is 600 here. These are opposite. Remember last week we talked about opposites? This one is 60. This is opposite. So let's just call this D for distance down here. So remember, if we have opposites, what we can use? Yes, law of sines. So we can say the sine of 60 degrees over d equals the sine of 40 degrees over 600. Good morning. Over 600. So then we can just perform that operation and we can say d equals the sine of 60 degrees times 600 divided by the sine of 40 degrees. Not too bad. And so D is approximately, if you do that operation, 600 times root 3 over 2 over sine of 40 doesn't come out nicely. That is, I hate this. Hate doing this to you. But I'm going to 6428. Check me on that. I could be wrong. Notice we're in degree mode in our calculator, and that is approximately 808 kilometers. And that's a reasonable answer. D is going to have to be a bit longer than 600. So that makes total sense. And then the next, we can continue that same process, and we can do sine of 40 degrees over 600 equals the sine of 80 degrees over, we need a different one. What we use D for that. Let's use, I don't know, S for the section that we went south on, I guess. So we can say over S. And you're saying, where did he get the 80 degrees? Well, I had originally suggested that this little guy in here was 40, but I was wrong. It has to be, this is 90 in here. So if this is 40 and this is 90, then the triangle sum theorem tells us that this purple one in here has to be 50. It's just that my scale was wrong. Hopefully you'll draw yours a little bit stronger than that. Okay, so we have sine of 40 over 600 equals sine of 80 over S. Here's my 50. The red one is 30. Put them together, you get 80. Opposite of that 80-degree angle is this distance S, the southern leg of our flying journey. And I want you all to find out what S is equal to. S, I was going to go blue on that. So take a moment now, pause the video if you want to, and see what S is equal to. Okay. And if you pause it, I think I'll put this in here. Okay, so now you should have found that S is approximately 919 kilometers. Okay, so now you know that D is 808 kilometers here. S is 919 kilometers. Put them both together, what do you get? You get 2,327 kilometers for our total distance flown as your flight school, which is pretty cool. Okay, I like it. Let's find one for you to do. Okay, I'm going to pause now just to make this go a little faster. Okay. So your challenge is you're starting at Mary's Peak and you hike on an azimuth of 130 degrees using your handy little compass and app on your phone for a distance of 4.5 miles. And then your phone runs out of power, but you still have your handy dandy magnetic compass, and you're able to measure that you're hiking for you don't know how long on an azimuth of 250 degrees. Finally, you're starting to get hungry, and you see Mary's Peak through the trees, and you hike back to Mary's Peak on an azimuth of 20 degrees. Your goal is to find out exactly how far you have hiked so that you can calculate how many calories that you've burned, so that you can figure out how many nasty French fries and burgers you can eat to reward yourself for returning to your car alive. That is all. Have a great day. Math is good.